Well, I'll start us off then, I think, because people are coming in quite fast now. So, yeah, hi everyone. Welcome to the latest Golang Live event, part of our live series over at Amicus Recruitment. This one is Golang Live. This one is titled The State of Kafka and Go and How to Develop Kafka-based Go services in 2020. My name is Jake O'Regan. I am the Golang specialist recruiter over at Amicus Recruitment, specialising in German companies. My colleagues do London and Amsterdam-based companies, and we also do remote companies in Europe as well. So without further ado, I'm joined today by Dino Omanovic, who will be leading the webinar. It should last around 45 minutes or so. We have agreed that if you do have any questions throughout, then Dino has given me permission to interrupt him as he's doing his presentation, and I will ask the question to Dino, who should answer. We'll try to keep it as interactive as possible today. So yeah, without further ado, over to you, Dino.
Hi everyone. I'll share my screen now, so I hope you'll see the presentation. Give me 1 second. It should be visible now. All right. Today I'll talk about, well, the state of Kafka and Go, and specifically about the library ecosystem, testing, and some best practices I've come across the years. First, I'll start with a short part about myself. Well, I'm Dino Omanovic. I'm a systems architect, IT consultant, senior Go engineer, and also a Go trainer. Well, with the recent situation, I haven't done a workshop in quite some time, but hopefully that'll change. Yeah, I've been working with Go in production for over 5 years now, and also with microservices and in agile teams for 9 years. If you want, visit my homepage, gomano.de. Well, it's in German, but English will be coming soon. There are some more talks and some 2 Golang courses and some other stuff there. Add me on LinkedIn if you want to discuss something, if you're interested in anything really doing business, just contact me and I'm happy to accept your invitation. Also, you can follow my GitHub, and if you add me on LinkedIn, I'll share the slides later, but also this will be recorded. Yeah. Thanks, Jake. So we'll see that later.
This will be recorded, and there'll be a link available for everybody if you do want to recap on anything that's been said today.
Correct. Okay, let's start. So today we'll talk about a few things. First, well, I assume that most of you know Kafka in some way or other, but still I'll do a really fast introduction into Kafka and what it does, where I should use it. After that, I'll talk about the state of the library ecosystem, or the Go library ecosystem. We'll talk about testing challenges and specific testing tips. And we'll end with some patterns and best practices. If you work with Kafka and Go, there'll be some generic patterns and best practices, but also some very specific to Golang. I'll not be talking about the Streams API of Kafka. So this is a library for JVM-based languages. I'll not be talking about KSQL. So don't expect that. You can still use it because it can be used with a REST API. And I'm not going to talk about Confluent Cloud. And what I forgot to mention is I'll not be talking about the schema registry either. So because this talk would not be enough to cover these topics. If you want to talk about them, message me. Okay, let's try to explain Kafka in 3 minutes or less or more. We'll see. So Kafka basically is just a log, right? So a log is a tool or a file where you just append stuff. So basically, you just add and add and add stuff. And the way this works is that some producer, which would be a microservice, for example, writes bytes into the log, and these bytes just get appended. And these have an offset, so you start at 0, and for every message or every value that gets added, the offset rises for I don't know. Well, it's just an integer really, and you have consumers which can tell Kafka that they want to read from a given offset, and then they'll get messages starting from that offset, and the Kafka will read it serially and send it to them. These logs are actually just files on the hard drive or SSD, and they are organized in segments really. So depending on the configured segment size, a log will get cut off after reaching the defined size, and a new file will be started, which is important for Kafka semantics, but I'll not get into too much detail here. And Kafka is comprised of a lot of topics and a bunch of logs actually. So a topic consists of a lot of partitions, and one partition is actually a log which gets replicated to multiple Kafka brokers. And producers write to a Kafka cluster, and depending on the key and strategy, the messages get written to a specific partition or log, and consumers then can either say, I want to consume this specific partition, or they can be part of a consumer group, which allows Kafka to manage that for them and distribute reads across the whole consumer group. Well, Kafka is very fast. So Kafka is only limited by disk I/O because it's serially writing and serially reading. So it's extremely fast, and it can overwhelm services if they are not fast enough themselves. That's why Go is such a good match for Kafka, especially because it's well, let's say a functional-ish programming language. So you have a very pragmatic approach to structuring your application, and you can use functions as handlers. Go is easy to deploy, so you can deploy lots of small Go units or microservices. It's fast. Well, it can be slow if you program it wrong, but that goes for everything, I guess. And also, you don't need to have object-oriented overhead. So you can just work with bytes and let's call it primitives, and not have a lot of overhead for object-oriented stuff for every value you read or copy. Also, you can control yourself if you want to do calls by reference or copies by reference or copies by values. So you have control over pointers, and you can decide if you do want them or not. So it's quite a good fit if you want to scale up and do a lot of heavy lifting. Let's dive in. So we're talking about the state of the library ecosystem in Go for Kafka, and mainly we're talking about 4 different libraries here, which I know of. So if you happen to know about a library which is stable and in a good state and is maintained, feel free to write me a message, and I'll update the talk or the slides accordingly after, not right now. So we'll start. There's a library from Confluent in C. Confluent are the makers of Kafka, and there's a library from Shopify, which you probably know, which is a shopping or e-commerce platform. There's a library from Louvo, I think they're called, which is something like Tinder. And Segment.io, or I think now it's called Segment.com, also has a library. I'll go through each of those with some code examples. This part will be a bit code heavy. The later parts won't be. So, but it's more about the structure. You don't have to read every line in detail. We'll start with the official library, I guess. It's based on an, I forgot a word there, based on an official CLib, and The CLib is called, I think, librd-kafka, and it is, well, it's officially supported, so you get all the new features here at first. So if you're really dependent on every new feature or all features, this is the way to go. It has a very language agnostic API, so if you have a lot of different languages and your organization is polyglot, you should maybe think about using this library. It's licensed under Apache license 2.0, if that's relevant to you. Let's look at the code. So the first thing we notice is that CGO is required. So this is really important. If you use this library, every service you write will have a dependency on CGO, and as Go developers know, CGO is not Go. So you lose a lot of stuff, and especially in my experience, it gets difficult if you want to monitor or benchmark or look at dumps from running services to see how memory usage is, and if a lot of it is happening in C, you lose a lot of visibility. So keep that in mind. Also, the building process differs quite a lot. You can create a consumer which will read from Kafka with a configuration you can give. And one difference to the other libraries is that you have to specify a group for a consumer group. So there's actually no official way to just consume single partitions without consumer group handling. To opt out of it, you have to assign unique group IDs for each consumer so that you can really start to control which partitions you will read. Something I didn't see in the other libraries is that you can use regexes for topic names, so you can actually collect or consume from multiple topics with just one regex, which can be quite nice if you have naming schemes with, I don't know, minus number or something else to distribute your messages or events. Or you can just list topics you want to listen to. After that, you have a loop, and there you read messages, you get Kafka messages, and then you can work with those. One thing you probably notice if you're a seasoned Go developer is that there's no context passed anywhere. So usage of the context package is not part of this library. So you have to manually close and manually gracefully shut down manually the library and the consumers, which is not the worst thing, but it's not very idiomatic. And usually Go libraries do support the context package right now. If you're on the producer side, the code looks like this. So you also pass a config with the Kafka brokers. You have to produce asynchronously, so you cannot just use a synchronous producer. You do have to manage this yourself if you want to use it in a synchronous fashion. So to listen on any events coming to the producer, you have to start a Go routine and loop over it to see if delivery happened and so on and so forth. Producing itself is quite straightforward. You just call produce, and it's also possible to write by using the channel. So there's produce, and there's also produce channel, which returns a channel you can write to. And yeah, and then you can pass partitions and so on. So producing is quite straightforward. Again, you have to manage graceful shutdown yourself, and context is not supported here.
Just got a quick question, Dino,
right,
that's just come through. So thank you, Fotis, for this one. Based on your experience, Dino, Is performance worse with the Confluent-kafka-go library compared to the other libraries because of CGO?
No, the performance is not worse.
Okay.
So actually, performance is really good for this library.
Okay.
They, if you look at the GitHub page, the argument for using it is that it's difficult to implement a Kafka client library, and they wanted to implement it on one place really well, and they did so in the C library. So it's really good, but it's written in C and is included via CGO. All right, let's continue. Let's go to the second library, which is Sarama from Shopify. It is by far the most popular Kafka library in the Go ecosystem. It's also the oldest, predating the official one by, I think, 1 or 2 years. And it's a pure Go implementation, but it passes around massive amounts of pointers, though. So be wary of that. You have to know this, and it's just the way it's implemented. So if you start to analyze dumps or look at Go routine profiles, you will notice a lot of entries for Sarama, which was quite confusing for us in the beginning. It's licensed with MIT, and there's an extensive Go documentation, but that's about it. So don't expect too much documentation here.
I've just got one more question. Sorry, Dino, it's just come through. Sorry to interrupt. This one's from an anonymous attendee, but whoever you are, thank you for the question. Can Confluent-kafka-go Kafka library work on the Apache Kafka?
Yeah. So everything works. I'm talking about libraries for Apache Kafka here.
Yeah.
So every one of these, well, this Apache Kafka is the Kafka, if I understood the question correctly.
Okay, I'll go with that.
All right, so the Sarama consumer looks a bit different. So it's written in pure Go. Actually, this example is from their code, so there's no import for Sarama here, but you do not need CGO. You have to define a handler, which you probably have seen in, for example, HTTP handlers in Go. And in the end, you create a consumer, whatever, a consumer group, okay? And actually here, there's context support for group consumers, so which is nice. You have to loop over the consumer because in case of rebalances, which is happening in Kafka if, for example, the number of consumers changes, if something like this happens, it will exit with an error, or I don't know if it's with an error, but it will exit. So you need to loop over the consumption here. Also, there's a second consumer, which is for consuming by partition and not managed by Kafka. So here, suddenly, we do not have usage of context anymore. We need to pass a list of partitions. Oh, it's cut off, sorry. Or we need a list of partitions so we can choose the partition we want to consume from, which is how you would expect. You can send a separate request for metadata to get this, and then it's quite straightforward. You consume by consuming a channel which has the messages and a channel which has the errors. One thing to notice is that the API is very different to the group consumer. So you have to differentiate here, and you have to learn 2 different APIs for these 2 use cases. There's another question I've seen, I guess.
Yes, it is just about if, yes, just Ulas has asked if this will be available for offline use later. Of course, yes, there'll be a link sent out to everybody in attendance.
Yeah, if you want to talk in PDF form, you can also message me on LinkedIn. I'll send it to you in PDF form. But a video is nice too because of the soundtrack, I guess. And producing is also quite straightforward, but in this case, the context is gone again. So do not expect a consistent use of the context package with Sarama. You can just create a message. And in this case, you have a sync producer, which is quite nice, which wraps asynchronous handling for you, and also an async producer. And you just create messages, and you send those either in an input channel for the asynchronous one, or you call send message with the synchronous one. Now there's a strange library, I guess. It's based in Sarama, Goka it's called, from Lovu. And it's not a general purpose API, but more like something like Kafka Streams API for Go. It's stream-ish on top of Sarama. So it introduces its own semantics and its own functionalities. So it's not general purpose, but can fit your use case. Also, I didn't explain it, but I show commit histories or active contributions for each, so you can estimate how well it is maintained. Those are the graphs on the right. So this is how Goka works. You have emitters, which is a concept they introduce, so stuff that sends. You have processors, which takes messages and does some calculations based on those messages in Kafka. They persist a table, they call it, in Kafka. So you can do stuff like joins or aggregations like you would in an SQL database. And in the end, you have views which collect the data from those tables and can do stuff with it. For example, create a REST API or a gRPC server. This is quite different from the typical Kafka stuff, but if you want to work with Kafka similar to the Streams API in Java, this is the way to go. I did not work a lot with it. We had one microservice with it, but we quickly went back and rewrote it in another library. The code, I'll just go quickly over it. It's a bit much. The code looks quite different, therefore. So you have emitters, processors, and in the end, what you do is you have a function which gets a context, and this is managed for you, and will get you the last message with the given key in Kafka, so you can do computations on it. There are also patterns for joins and stuff, but it's quite different. So you need to know that. If you just want to work with Kafka, how it's originally supposed to be, probably don't start by looking at Goka, which is quite different. Also, it has a, oh yeah.
Sorry, Dino, I was just had a question come through from Sarah Venan. So Goka has a feature similar to KSQ LDB.
Yeah, it's similar, right? So KSQL is just a SQL-like language to do stuff that Kafka Streams also could do. So yeah, essentially yes. But you can also use KSQL with Go, I guess, because you can just do it via a REST call. So maybe you can think about this if you think about using Goka.
Okay.
All right, and let's go to the last library, and after that we'll get away from the code and more to concepts. This is the youngest one by far. It's also a pure Go implementation, and it's quite idiomatic. So it fits in quite well with the way you're used to writing Go applications. It has the same API for partition consumers and group consumers. It's just called a reader, which you pass some configuration for. It supports context, and also for both of those readers, it supports auto recovery. So if a rebalance happens or a connection loss, it will try to recover for you, so you do not have to worry about too much yourself, which is quite a nice feature. I don't want to be impartial, but I do quite like it. The producer here is called writer, so probably if you've written some Go, you know readers and writers, and they're conforming to the naming convention here, but it's not the IO writer or reader interface, right? With the writer, you just pass it some config. You can pass one or more messages, and with the same writer, you can write synchronously or asynchronously. There's a flag for it here. And if you choose to do it asynchronously, it'll just skip over writing messages and you won't see if there's an error. So be aware of that. It supports context too, as the reader does. So here you have full support for Go contexts, which is quite nice and slims down the code for graceful shutdowns. So to summarize, if you need the newest features, use Confluent-kafka-go. If you need ACL support, so this full ACL support, so these are access control lists, which where you can assign who can access which resource. But you do not want CGO in your project, use Sarama. If you want something like Streams API in Java, you can use Goka. And for everything else, I do recommend Segment-kafka-go. Actually, we've migrated most of our services I've worked on from Sarama to Segment-kafka-go, and mostly it was a smooth ride. So that's for the ecosystem. Let's talk about testing. Testing in a Kafka environment is quite different. So usually we know about the testing pyramid. Oh yeah.
Sorry, I just had a question come through.
Sure.
Just from the previous slide.
Sure.
Yes. So Confluent-kafka-go doesn't support ACLs.
It does. Sorry, I just wanted. If you want this full support without CGO. So if you're dependent on this, but do not want the built-in dependency on CGO, go for Sarama. Actually, I'm not sure how good Kafka-go supports it because we do not usually have the need for it. But if you want to be on the safe side, go with Sarama for this use case.
Thank you.
So usually we're used of this concept of the testing pyramid, right? So you have massive amounts of unit tests, lots of component tests, less integration tests, and a small amount of end-to-end tests. There are different variations on it, but let's go with this one. My opinion is that smaller services mean that logic shifts away from code to infrastructure. So things that used to be, I don't know, modules or classes become microservices, or lambdas or serverless functions, whatever you want to do. And that means that the line between end-to-end tests or integration tests and component tests gets blurry. And if you want to have a really know if a commit you did breaks the system, you suddenly need to cover more than one service if you want to merge or deploy in your continuous integration pipeline. This ends up looking something like a rocket, so you still have lots of unit tests, but the middle part gets quite blurry. And this means that you start to write more tests that cover multiple services. And this is also a thing I recommend. Test your use cases covering multiple topics. So if you do computations over multiple topics, make sure that after a merge or before a deploy, you have at least smoke tests to make sure that you do not break the chain. Also, what I can recommend is that you roll your own test tooling for integrative Kafka tests. Everything out there sucks in some way or other. Every time we've used Kafka testing frameworks, libraries, or testing frameworks with Kafka libs for them, we've run into a wall. So especially they use different semantics, and sometimes you get confused because they use some word in the Kafka context which just is not correct or means something else than you would think. So if you have the time and you're working in a big microservice environment, create your own test tooling for Kafka. It also teaches you a lot about Kafka and is very helpful. Kafka itself is really rock solid, but your code not. So Kafka will recover if a single node fails and if it's configured correctly. And it will rebalance, select new leaders, which are things that just happen. I won't go into details. But you need to make sure your code can handle that and recover from it. So do chaos test, which means just shutting down random parts of your ecosystem on or infrastructure on CI. Recover and shut down gracefully. So test this by killing your service and restarting it inside a test run, and check if the Kafka topic is processed correctly. And in the end, test what happens if you lose your offset. So if you do not correctly save where you last read in Kafka, and you start again, this can really be bad. So in my experience, for example, this can mean that you resend all emails ever to every customer, which was not a great day. So be aware of it and do test it. It will happen to you at least once, and depending on your use case, this can be bad. There was another question, I guess.
Yes, I think it's more towards the end when we do the end questions and answers. Those, if we carry on.
And let's get to the patterns and best practices now. So I like to skip a lot, and I hope that you will be enlightened a bit after hearing this stuff. At least I hope so. So this sounds counterintuitive. Usually in a microservice environments or modern architectures, I think that the principle try or do not repeat yourself is a bit outdated, and you shouldn't create libraries for everything because it makes deployment and updates quite troublesome. But for Kafka, I do recommend creating your own a small library just containing domain logic. No domain logic at all, and just a boilerplate you usually do to create Kafka services. Also, this has a great side effect of onboarding being way easier for new team members, because they can start with an abstraction of Kafka which fits into your use case, and then as time goes on they can dig deeper. This is necessary because having a slightly different behavior in one of many services is nearly indetectable, and it will happen to you. So for example, if you just stop consuming one partition of many and you do not notice it, this is really hard to debug. And if somebody just had a typo or forgot a line when implementing the 50th service with Kafka, this can get really bad. So create a library after you've created, I don't know, 10 services or so. If you're in that in a project or product that's this big, it will help you. If you create a library, use Go modules, which were introduced quite a while back, and enforce semantic versioning so that it's clear when API changes mean that you need to touch code. If possible, auto-update your repos for minor and bug fix changes so that you do not have to rebuild every repo by hand. This is quite easily done with modern CI solutions. Avoid breaking the API at all costs, and I can only recommend a blog post from Dave Cheney, who is widely known in the Go community and he's talking about functional options for friendly APIs. Do read this article. If you don't read anything else or don't take anything away from this talk about Kafka, do read this article. It's truly great and will help you create stable APIs for your backends. After some time, essentially, you've written your own custom streamed API, which we've done, I guess, but it will be specifically for your use cases in your product, which makes it very, very useful. Do trust Kafka. Kafka is extremely stable and extremely performant. So there's something called the outbox pattern, whereas it's from Debatium.io, which is something like a adapter for databases, which reads from databases and writes events or messages from the databases to Kafka automatically. And the outbox pattern describes services that work on a database, and instead of writing to Kafka themselves, the database is used to propagate this to Kafka. This can be good if you have legacy systems that use databases and you want to migrate to Kafka, or if you have services that need this database anyways because it has some structural features or search features or whatever that you need. But a mistake a lot of people make is that they have a database for every microservice and they write to Kafka additionally. What this means is that you have a lot of databases that essentially are unnecessary because Kafka is highly available and persistent and will not fail you if you configure it correctly. Keep it simple. You don't need duplicate infrastructure for everything. So what we've done is in our microservice environment with hundreds of services is that we've just dropped most databases and we are accessing all data from Kafka. When we start the service, we read everything we need from Kafka, and we just use databases if we need their features. So, for example, Elasticsearch as a search engine, and so on and so forth.
Sorry, Dino, just a question that's just come through is, as a producer, how do we avoid publishing duplicate messages, especially in the case of restarting the service from the failure?
So Kafka assumes that you can handle duplicate messages. So this handling is left to you. So Kafka right now it has a guarantee for consumers that messages in Kafka only delivered once, but up until this point, it could also happen that you get a message multiple times. So your services behind Kafka should be able to detect that the message is a duplicate and be idempotent, which means that that a duplicate message should have the same effect as if just the message just came in once. If you, for producers, well, if you have asynchronous producers, just use those if you don't care really if all messages arrive. For synchronous producers, they will just continue after your message was persistent or Kafka has accepted it. So if you want to make sure that you produce just once, use a synchronous producer.
Perfect. Thank you.
To continue on this point, so you usually do not want to have a database for every Kafka service as a redundancy, but sometimes it can be good to have local databases for your services. So what we usually do is we start a service up. For example, if we have services that need to deliver messages from Kafka via a REST API, let's say articles or something, and usually we would read those into in-memory maps, for example. This can be expensive if your data set becomes too large, and then you can use the possibility of local databases, something like BoltDB, SQLite, RockDB, LevelDB, I guess, or other in-memory solutions. You have to decide you have to look at the amount of data you're going to process, and if there's a possibility that a local database can be used. This is a good pattern I found because file or disk space is very cheap, especially on cloud providers in comparison to RAM. So this is a way you can still reap the benefits from a microservice database. Something like you do not need to read everything at startup from Kafka, but still save money. Also, those can be integrated just into your code. Something like BoltDB is just embedded in Go and is really easy to implement. And if you want to be really fast, you can use something like in-memory databases or a in-memory map but this can get expensive for big data sets. Also, if you write a library for yourself, integrate this stuff into it, because you will get dividends from it, and it will pay off tremendously. So in our case, for example, I've written a service a few months back that delivers articles for a quite big e-commerce platform, and actually the service now only needs, I guess, 40 megabytes of RAM and can deliver I don't know, I think 200,000 products or something in JSON form, which is quite nice and extremely cheap in comparison to managed databases. Yeah, Murphy's Law is also in effect here. So anything that can go wrong will go wrong over time. So if you do not validate the messages in your Kafka topic, you'll have a bad time. Some invalid trash will end up in your topic, for example, invalid JSONs. And if you just exit on an error, then your service will go down and it'll be in the middle of the night and your services will stop working. So if validate your messages, or if you transform them into JSON, for example, just skip those that cannot be marshaled. I always mix those up. And that's it, just skip those. Especially if you're working with stuff like SAP, they have this illness of just deciding what kind of JSON type fields are on the fly, so be aware of it. Offsets will get lost, so sometimes if you have a consumer group and you configure it or not configure it correctly, consumer group offsets will be lost and you'll start consuming from the beginning or the end, whatever the default is for your library or your the stuff you configured. And you will either lose some messages without noticing, or you will reconsume everything in a consumer group, which goes back to the email example I just talked about, with sending all emails to every customer in history again, which was quite bad. And also partition connections will be dropped. So if you write a service without consumer groups, which connects to all partitions in a Kafka topic, it can happen that single connection will be dropped. And if you do not notice it, you will ignore one partition out of 30 or whatever and not notice it, which is quite hard to debug. So do test these things. Also, talking about logs. Some question.
Yeah, so question there. What's the best technique to handle lost offsets?
So for consumer groups, in Kafka you can configure offset log retention. So be aware that consumer group offsets will get dropped after some time without an active consumer group. If you know about the setting, you can adjust it accordingly. And the alternative is persisting the offset somewhere else, which you would do if you do not use consumer groups anyways. But be aware of the configuration parameter of offset, consumer group offset retention, I think it's called. Offsets in Kafka for consumer groups are just topics themselves. And if a consumer group is inactive for a while, it will drop those to save space. It's a Kafka configuration. Right. Be sure to understand log retention. So logs in Kafka or topics have different configurations on how long they keep messages. Topics will keep growing and messages will get deleted. So if you don't get this right, either your topic will become increasingly big, which can be a big cost factor, or messages will get deleted without you understanding why, so, which can be business critical, really. So if you use topics with full data sets, something like stuff like articles or stuff that would be in a database usually, you can use compaction, which is a technique from Kafka where Kafka deletes all messages except the most current one with the given key. for example, I don't know, some ID. And this way you can keep your topic very small and be sure that for every entity that is relevant, you have at least one and the most current entry. If you do not use compaction for stuff like events or logs or metrics or whatever, choose your retention periods carefully. So if you do not think about it, after I think the default is, I don't know, 2 weeks, I forgot the default, stuff will just get chopped off the end of the log. And if you do not notice and you expect to have a full import of all your, I don't know, price data or anything, and suddenly you don't have it, this can bite you.
Just had confirmation it says 2 weeks as well in the chat.
Oh yeah, all right. Then I've remembered correctly. Also, if you, so be aware of it and adjust it according to your needs, and but think about costs of storage as well. All these things I've mentioned don't have any effect as long as a segment is not written. And default segment size is 1 gigabyte. So 1 gigabyte can be a lot of data. And if you do not notice, this will mean that you're expecting compaction to kick in and to clean up your topic, but nothing's happening, even if you configured it correctly. So if you have topics that don't have a lot of data, you can decrease segment size down from 1 gigabyte, and this will mean that you will consume less space and you won't have to pay as much for space in the cloud. So look at the segment size configuration and look at especially what it does later on if you want to save some money. In the end, well, this could be part of testing too, but in such an asynchronous system as Kafka, it's extremely important to load test and benchmark your services, because in a chain of topic aggregations or calculations or whatever, or transformations, the slowest service will determine overall speed if you do not scale accordingly. So in your client libraries, you can play around with buffer sizes, how many messages are read from Kafka in one go. So play around with those, so you need to make a trade-off with memory and how much you can process. Scale according to service requirements. Some transformations just take a while. Maybe you need to make a network request to get information you need to do the transformation. So these services probably will take a while to do their transformation, and identify those and scale them up so that your chain will not get slowed down. Adjust mem limits. This is something we've learned in production, I guess. For some libraries, or I think actually should be all of them, less memory does not mean that your program will crashes necessarily, but if you do not have enough memory, this will mean slower consumption and more CPU load, because you can't fit all the messages you could read into RAM. So if in doubt, increase the mem limit and see what that does. And especially if in doubt, just use pprof. So profile your Go microservices, and you will see where you use up memory or CPU or Go routines. This is extremely valuable if you use a lot of Go routines in a Kafka context, because you probably do. And it's extremely confusing if you're using Sarama, which is why I advise against Sarama if you can use the Kafka-go library from Segment, because Sarama is using a lot of pointers, and we've been very confused looking at dumps from Sarama and profiling those. And the last thing I want to mention is save yourself a lot of headaches and just monitor Kafka. It's easy. There are Grafana plugins for it, and you can see stuff like consumer group lag, so you see when messages get in and don't get consumed, or if they're consumed slowly. And you can see how many messages are coming in, how many are consumed, how many messages are coming per second, how many petitions you have, and the configuration and so on. So this saves you a lot of time during the day and in production if you're just looking at the operations and how everything's working out. All right. These are my 2 cents about Kafka. Thank you for listening. I hope that you at least learned something you could use in production, or or maybe you have some motivation to use Kafka now. It's really easy. Start with the segment library for the lowest friction, and play around to learn the concepts. It's important to understand Kafka concepts before you use it in production, and do not use it just like a typical message queue, because that will bite you. Yeah, that's my last words.
Well, thank you very much, Dino. So we have got a few questions that have come through. Am I right to just read these out to you, or do you want to pop on the Q&A to have a look through as well?
If I can. I'm not used to Zoom. Just give me a second. I'll stop the screen sharing, and I can.
Okay.
Oh, Q&A. Yeah, I can see it. So, based on you explaining, I do get an idea of these questions, but I still want to ask: what library is more performant? Which one is good for code and memory observability? Which one is developer friendly? And which one do you recommend, and why? So regarding performance, many people have said that they think that the segment library is not really fast enough. I can not. I do think differently. We've used the segment library Kafka-go, the last one, extensively over the last year, I think, and it was fast enough for even heavy loads. You just have to do some memory tweaking and adjustments. So at the end, I don't think there's too much of a difference. I think Sarama is a bit faster than the Kafka-go library, but it does a lot of pointers. It creates a lot of pointers, so garbage collections kick in quite heavily. So you have to see what that means for your service. You'll notice I'm a fan of one especially. So which one is good for code and memory observability? By far the best in this regard is Kafka-go, because it's not using CGO, so you can profile it really well, and it doesn't use as many pointers as Sarama. So it's easier to understand where memory is going. And also the API is really developer friendly, in my opinion. So I've had some really good experiences and can only recommend it. I do not have, the question was if I have any experience using the Kubernetes operator. And I do not have any experience using the Kubernetes operator with Kafka and Go consumers. I'm sorry. What export class can be used to extract Kafka metric info for Prometheus and Grafana? I think there are 2 main ones. If I go back, let me see. I think one is Kafka Minion. So this is the one I've shown in the monitoring slide. Kafka Minion is the one you should try, I guess. I think we use it too in production. Do you have a recommended strategy? Oh, hi, James. Recommended strategy for handling retries in Kafka. So we've done different stuff. I do not recommend retry topics. So you would call it dead letter queues probably in standard messaging systems. And in my experience, this leads to a lot of problems. So if you can, just wait for the problem to resolve. If you can't, log it accordingly and look, maybe you can handle it manually later on. Or what we've done is, in this case, we use a database and save, if we have something that is very likely to fail sometimes, we use a database to write jobs from Kafka, and then we iterate on the database entries and retry from those, which is way easier than simulating a dead letter queue in Kafka. Basic question, where to use Kafka against MQTT brokers. Well, and there's RabbitMQ and SQS. So those are all quite different and not just MQTT brokers, but you can use Kafka for MQTT. So there's an MQTT connector for Kafka. I've not used it myself, but I think I've heard it's very good. Regarding RabbitMQ and Kafka, I think you need to ask yourself, how much throughput will I get? If you have something like up to 10,000 messages, then you can use RabbitMQ. If you anticipate going over 10,000 messages, do use Kafka because it scales really well. RabbitMQ is simpler to implement, especially because of error handling and retries. So if you know you won't ever go over 10,000 messages per second, or 1,000 persistent messages per second, feel free to use RabbitMQ. It's fine. I don't have a lot of experience with AWS SQS, so I cannot answer on that.
Thank you very much, Dino. If anyone has any last minute questions, now's the time to pop them over. But as they come through, I just wanted to remind everyone that Dino has obviously volunteered at the start. If you do have any questions that you want to reach out to him, please feel free to add him on LinkedIn. He's happy to accept and get into any conversation.
Also, a fun fact, if you've ever used LinkedIn, you've used Kafka. So LinkedIn are the driving force behind Kafka, and every message you get is coming over Kafka. So this way you use Kafka. Yeah.
Cool. Thank you very much. So that's good.
All right.
And also this is being recorded, so there will be a link available for everybody. So if you do want to go back, if there's something that you missed and you wanted to make notes, there is going to be a full recording available to everybody who's attended this evening. But the questions seem to have stopped, Dino. So thank you everybody for attending. Dino, thank you. You've been absolutely brilliant. Very, very informative. The guys it was really interactive. Lots of good questions coming through. Well answered. And like I say, anyone who wants to reach out to myself or Dino, please feel free to do so. And the link will be available for everyone tomorrow. So thank you very much. Have a great evening. Hopefully speak to you soon.
Bye.
Cheers, guys. Thank you.